Hello, welcome to Touchlab's summer streaming series. Today we're going to have a talk by Thaddeus and Philip, the brains behind our tool SKIE. The talk is called Close the Platform Gap with the Bad Swift Simulation. We'll be having a live Q&A directly after the talk ends. During the video, you can leave your questions in the comments section. We'll be in there as well while the video is playing, so maybe a little back and forth, see how it goes. Down below in the description, you can find the link to the simulation code and other content. So thanks for joining us. We're going to be having a whole bunch of content coming out soon, so follow us on the various socials.
Hello, I'm Philip and I'm a senior Kotlin developer at Touchlab. Today we will discuss the Kotlin to Swift interop, its limitations and the problems these limitations cause, and also we will discuss how to deal with them. Before we begin, let's answer why this is such an important topic. And in order to understand that, we need to look at the primary reason KMP adoption fails in teams. If you've ever worked with KMP, you've probably run into a bunch of technical issues that you had to solve. And therefore, you might expect that it's the technical problems that other teams can't overcome. But that's actually not what's going on. You see, we are developers, which means we are generally capable of dealing with technical problems. On the other hand, we are not that good at dealing with people problems. And it turns out that it's the people problems that teams struggle with the most. To illustrate this, I will tell you a hypothetical scenario that unfortunately happens way too often in practice. So in this scenario, we have a team of Android and iOS developers that work on an existing application, and they decide to introduce KMP into their codebase. In general, this will be initiated by the Android developers because the KMP is much closer to their tech stack than is the case for iOS developers. At the beginning, there will be just a couple of Android developers, they will quickly convince the rest of their team, and then together they will present this to the management and to the iOS developers. They are usually quite successful with the management because KMP has, at least on paper, a lot of interesting benefits that are easy to explain to business people. On the other hand, they often struggle to convince iOS developers, and sometimes they don't even convince a single one, but basically never they convince the entire team. However, because they've already managed to convince the management, they have enough decision power on their side to force the KMP adoption anyway, and they start using KMP even though the iOS developers might not like it. As a result, the KMP is used for a while. But if you look closer into the team's dynamics, and especially if you ask iOS developers, you will realize that the situation is not as great and that it looks like this. As a result, the iOS developers will complain, and over time they will complain more and more, to a point where the management will no longer be able to ignore these complaints and they will have to do something. The only thing they can reasonably do is to create guidelines and rules for how KMP should be used, what should be shared, when, why, who has to approve what, and stuff like that. And as with any processes, this creates a lot of friction. And especially, this creates a lot of friction for the Android team who will end up writing all the Kotlin code. The Android team will soon realize that they suddenly are much less productive than they were before KMP, and they start to complain as well. In turn, the management suddenly is unhappy because now they have two teams who complain about KMP, and together everyone universally agrees that the best course of action is to abandon KMP altogether. Great, so how do we avoid that scenario? That's actually surprisingly simple. And the answer lies in this story. The issues started right at the beginning of it, when the Android team decided to use KMP even though the iOS developers didn't want to. So what we must do differently is we must make sure that it's the iOS developers who actually want to use KMP so that they also contribute to it and therefore they are invested in making it succeed. Easier said than done, so how do we do that? That can be summarized in a simple sentence. We must make sure that they have good developer experience. And this is where things get a little bit more complicated because there are many things that go into it. But in general, unfortunately, the iOS developer experience with KMP is currently not great, and it's probably the biggest weakness of KMP at the moment. So we must make sure that we are addressing this correctly. And there are many things that we can work on improving. The first one is the topic for today's talk. It's about making sure that the Kotlin API is friendly to the Swift part of the codebase. But there is more. For example, the iOS developers must be able to modify the shared code written in Kotlin. And there are two extremes of this. In the first extreme, the iOS developers do nothing, and they just write their Swift code, they call the Kotlin code, and that's it. The issue with this approach is that imagine how we would feel if suddenly someone came and tell you that from now on you can only change the UI code in your Android application and all the domain logic and code around that is handled by some other team and you had to fully rely on them making sure that everything works and so on. On the other hand, if they are forced to write everything in Kotlin as well, they probably do not have the necessary expertise nor the means to do so, and they will struggle to deliver code and therefore they will feel miserable. So we need to find something in the middle, and that means that we must make sure that they are capable of modifying the code. They must be allowed to, and technology-wise, there must be a way for them to modify the code, but they cannot be forced into doing so. Instead, everyone on the iOS developer team must adopt the Kotlin code at their own pace and learn it on the way. They should start with some simple things like fixing bugs, changing behavior, and maybe small features, and later down the line, if they feel that they are up to the task, they can start developing like a lot of code in Kotlin. Another important issue that we are facing right now is with the debugging. If you've ever tried to debug Kotlin code in the native environment, you probably know that the best course of action is to hope that the issue manifests in the JVM target as well and go debug it there. And that's unfortunately really the best option. Fortunately, things are improving on this front because recently we've released Kotlin Xcode plugin 2.0, which significantly improves the debugging experience of Kotlin code in Xcode. So definitely check it out. And another point that I wanted to make is that you must strive to provide the iOS developers with a short feedback cycle. That mostly means short compilation times in our case. And the issue there is that recently the iOS developers got used to having quick compilation times, and that's because of improvements in the Swift compiler, but also on the hardware side with the new ARM CPUs. But if you've added KMP code into the code base, you've probably noticed that the compilation times suffer from that, and sometimes quite a lot. The truth is that the Kotlin toolchain for native isn't the most optimized because it's still quite young. So hopefully things will improve there, but at the same time it means that there is not much you can do about it. On the other hand, you can do a lot about making it worse. And while working with our clients, we've seen a lot of the times that they have their project misconfigured to a point where their compilation times can be even multiples of what is actually necessary. And that hurts the developer experience really significantly. So like one piece of advice that I can give you there is that you should make sure that your compilation times look reasonable and that there isn't really something really terribly wrong. Unfortunately, this is easier said than done because unless you are optimizing such build tool chains every day, you probably don't have the required experience. And in that case, the best thing to do is really to ask some consultancy company to help you in that area. And there is actually a lot more, but these are the main points that I wanted to talk about today. For now, let's move on with the main topic. And that's the problem with the Kotlin API in Swift. Let's begin with explaining how the current Kotlin and Swift interop works. Right now, as you might know, the Kotlin and Swift languages cannot talk to each other directly. Instead, they have to use a middleman called Objective-C. Both Kotlin and Swift can talk with Objective-C in a reasonable way, but unfortunately, that doesn't automatically mean that the interop between Kotlin and Swift is good. The issue here is that Objective-C is quite an old language at this point, and therefore it doesn't have many of the modern features that we are used to in Kotlin and Swift. And because Objective-C doesn't understand these features, it cannot pass the concept of this feature from one language to the other language, and this feature in this case gets lost in the translation process. But contrary to popular belief, this isn't the fundamental problem of the interop. It's like the most famous one because it's the one that you will see immediately when you open a project, but there are actually two more fundamental problems here. The first one is technical, and we will explain that a little bit later. The second one is another people problem, and it's a problem with us, the developers, because we do not think about this issue enough, and we do not give it enough credit, and therefore we, in our negligence, make things much worse than they actually have to be. That brings me to the idea behind this code lab. Our goal is to give you a perspective of the iOS developers so that you can understand what it's like to use the Kotlin code from Swift, and so that you can appreciate the pain that they have. How we will do that? Well, generally, this is done using examples, and you usually have some Swift, and you look at the Swift, and you see the issues there. But this approach has a problem, and the problem is that unless you are an experienced Swift developer, you can't, you don't fully see all of the issues in there, because you don't fully understand how it should look like ideally. And unfortunately, we can't turn you into an experienced Swift developer in 45 minutes. That's not realistic. So we've chosen a different approach. Instead, we will explain you all these examples in language that you already know very well, Kotlin. How we will do that? That's a question for Tadias.
Let's take a look at our bad Swift simulator. It's an Android Compose app that depends on this SDK module, and the SDK module has two variants, good and bad. The good one is regular Kotlin library with all the bells and whistles you expect, like sealed classes, suspend functions, and flows. Whereas the bad one is our simulation of how the same API looks like from Swift. So let's take a look at the app itself. We'll go to the app, good, source, main, Java, all the way through packages to cases. And here we want to open the enums view file. So enums in Kotlin are exhaustive, which means when you use the when expression, Kotlin will make sure that you handle all the cases. So in our case, we have apple and orange and we need to handle both. If we remove one of them, it will complain and tell us that we need to add remaining branches. So this is the exhaustibility of the enums. Let's go to build Gradle KTS and comment out good, comment in bad, and resync. We already see issues. So the first issue is get favorite fruit is no longer available. That's because it was a global function before, and global functions and global properties are not available in Objective-C. Therefore, Kotlin has to find a way to work around that, and the way that's done is there is a file class generated which has the name of the file, so enums.kt, and then inside of it we have class functions and properties that replace the global ones. But Kotlin is still not happy about this. Why? So it's the exhaustibility. So we need to add an else branch and handle it. And now we're good again. But the problem is we just lost compile time safety. Because if we add a new entry here, it will crash. And that's what we already did. If we go to fruit here, we see that there's already pair. And so if the get favorite fruit ever returns a pair, this will crash. Similarly, sealed classes and interfaces also allow us to use the when expression to make sure we handle everything. So in here, we use this Reactor class, and let's take a look at what it is. So Reactor class is a regular class with a very simple class with a condition property, and then condition is a sealed interface. And that sealed interface has three implementations: shutdown, subcritical, critical. And then down below, we have an extension function on the condition, human readable description, that returns a description of the condition. If we go back to our sealed view, let's do the same thing as we did with enums. We comment out something, and then Kotlin complains, add remaining branches, Kotlin is happy again. So now we want to go back and go to the build Gradle and comment out good, comment in bad, resync. And now there's a lot of red. So let's tackle it one by one. First off, in Swift, protocol and also Objective-C, protocols cannot be nested in each other or in classes, and classes and other structures can be nested in protocols. So Kotlin has to, again, work around that, and the way it does it is that all of these become top-level symbols or classes. So we've handled that, but now the same issue with enums, we need to handle an else branch. So not happening. But again, if someone comes in and adds a new implementation, this will not complain in compile time and will crash in runtime. So this is not safe. However, we have one more thing to fix in here, and that's the human readable description. Similar to global functions, extensions on interfaces have to be called through the file class. So in here, we have to do sealed kt dot human readable description and then give it the condition as parameter. So now that we have this set up, this will work, this will compile, but we've lost the compile time safety in here. Next up, we have coroutines, and we have those split into suspend functions and flows. We'll start with suspend functions. So we go into suspense view, and it might be a little daunting at first, but it's quite simple. What we do here is we have a button that, when clicked, will start getting fortune from our fortune teller. And when it does, it shows it below it. But we can also cancel it, and then we just don't want the fortune delivered. So let's see, get fortune, cancel, nothing happens, get fortune, wait, and we get the fortune. Let's switch to the bad SDK. So after a sync is successful, we don't see issues with the code. We don't see any compile time issues. And it's because everything different here happens at runtime. So we rerun the app. Now if we get fortune, we got it. Perfect. But now if we get and cancel, we still got it delivered. Notice the fortune still delivered after cancelled is here. And it's not supposed to be happening. So this is one of the semantic changes between Kotlin coroutines, how they are called in Kotlin, and when they are called from Swift. Because there is no cancellation support. So no matter what you do, once you start a coroutine from Swift, there is no way to cancel it. That leads us to flows. So for flows, we have this traffic light here that we can toggle on. It starts going red, green, yellow. And then we have a counter underneath that says how many times we got the update. So that goes up. If we toggle it again, it stops going, the traffic light is off, and the counter stops going too. Switching to the bad implementation, to the bad SDK, we already have a compile time error. So there's another source difference that we need to take care of. We actually need, instead of a lambda, we actually need to provide it an instance of a flow collector, which is an interface, and I have one here. So let's use that and just rename it so that the name matches. So we use file collector is our flow collector, and then we want to give it the same lambda that was there originally. And then we just pass the collector in to the collect. But that's not enough. The new light state that was originally string is string no longer. Because flow becomes an interface, well, flow is an interface, but in Objective-C, interfaces or protocols cannot have generics. So we lose the generic argument, and therefore new light state is now any, and we have to cast it to string ourselves. We also have to hope that we've got it right, because from the signature of the getTrafficLight, we can't really know what it returns, because all we get in Objective-C and in Swift is the Kotlin X Coroutines core flow name. So if we run this and we toggle it, it works. So we've implemented the flow collector correctly. But the problem is with cancellation the same way in suspend functions. Because the traffic light flow is infinite, when we toggle it off again, it keeps going. The collect doesn't stop. So if we toggle it multiple times, it starts going real fast because all of the flows are now running in the background. Let's have a look at a simpler example, and that's default arguments. So default arguments in Kotlin and Swift work slightly differently, but both of the languages have them. Unfortunately, Objective-C does not. So even though our constructor here takes in offset and defaults to 0, and get favorite numbers that multiplier that defaults to 1, once we switch to the bad SDK, we'll see how Swift sees this. Right away, it just tells us you need to pass a value for the parameter. So because we don't know what it was, we can put in something that and we hope is the default value, but it probably isn't, right? So the problem is, again, then from the signature itself, you don't see it. So if we look at the signature, it's just offset. We don't see what the original default value was. And then our Swift developers have to pass in hopefully the right default value if they want to use the default. Lastly, we have somewhat complex example, and that's for generics. So Objective-C does support generics for classes, However, because it was an afterthought and bolted on later when Swift essentially needed it, they are somewhat limited. Kotlin and Swift generics are different too, but they have some similar features that are lost in translation. So let's take a look at the generic showcase class here so we can see what we are dealing with. The generic showcase is a generic class. It has the generic parameter t and then a property value that is of type t. Then we have function. This keeps generics. That returns t and really returns the value. Then we have this map also loses generics, which right now is a misnomer because in here we have generics and everything should work as expected, and it maps the value property to whatever we want. And then lastly, this loses generics extension function on the generic showcase class just returns value. Simple enough. So let's look at the use case. Here we just take the value, and as you can see, everything it's integer, 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 and string. Everything works as we would expect. Compile time save, perfect. The value here, I want to point out, it accepts just integer. We can't give it null, we can't give it anything else. Perfect. Let's switch to the Bats SDK. Right away, we'll see issues here. The first and the most important one is that nullability is declared differently between Objective-C and Kotlin. So while in Kotlin, the generic showcase had type parameter t, which now has integer, Objective-C requires to know upfront whether that will be nullable or not. So because we didn't give it the boundary to any, all the generic types used are basically nullable now. So the integer here is integer optional, and then this keeps generics is also returns optional integer. So we have to force cast it to get our integers. But then this loses generics, actually does lose generics, because extension function has to declare the type parameter so that it knows what class it extends. However, function generics is not supported in Objective-C, and therefore it does not propagate to Swift. So here we have to cast it to integer. And then lastly, the same thing, this map also loses generics. It's a generic function, and then the return value is any. So we need to cast it to string. This is all runtime. These are all runtime operations. So if we mismatch it, it will crash at runtime. Worst of all, in here in the constructor, we can actually pass null, and it will crash the app because we first unwrap it here. But it's generic showcase integer, so we may not expect that to happen, but unfortunately it does. We couldn't cover all the issues that are created on the boundary between Kotlin and Swift. But let's take a look into Xcode to see that we didn't make any of this up and that this is really the case, and also what can be done with it. Because we've seen these issues happen time and time again, and there were a lot of workarounds and a lot of companies actually created their own generators for working with enums and CL classes, etc. We built SKIE. Now, SKIE is a compiler plugin and a tool that generates some Swift and then bundles all of that into the original Kotlin framework to improve a lot of the cases that we've covered today. Let's take a look at these cases and see SKIE in action. First up, enums. Simple enough. We see a switch on the getFavoriteFruit. As you can see, we need to use enum kt, and then we have case apple, case orange, as well as the default. If we remove that, Xcode is gonna tell us that it has to be exhaustive, but it will only give us the default, which is not what we would want or expect. If we look at the Swift enums view though, the SKIE enums view, SKIE not only brings back global functions, so we can use getFavorite directly, but it also gives us exhaustivity, so that we only cover Apple and Orange. And if we remove Orange, Xcode will give us exactly that case. Now the same applies to sealed classes, or in our case, sealed interfaces. So in Kotlin, as you can see, we switch on the Reactor condition, and then we need to use this case is and give it each of the possible implementations, or default. And then again, if we remove any of this, all Xcode will autocomplete for us is the default. The same way in Kotlin we've seen how the human readable description from the bad SDK had to be called is visible here. It's the same thing. So in SKIE sealed view though, we use this function onEnumOff and we give it reactor.condition. And what it does for us, it converts the sealed class shortly into an enum so that we can switch on it the right way. So if I remove critical, Xcode will complete critical for us, as we would expect. And then also one nice thing is that Reactor condition now has human readable description directly on it, because SKIE brings that back. Following up with suspending functions. As you've seen in Kotlin, this is a very similar code, and when we get fortune and cancel, fortune still delivered after cancelled. If we just get fortune, we get the fortune as expected. But there is no cancellation. Whereas in SKIE, and we will have to run the SKIE app for this, the code is quite similar and it's still the try wait to get fortune here. When we go to the SKIE app, which I will open in a minute, here. If we get fortune and cancel, nothing happens. We are back when we were. Get fortune and wait. Now we have the fortune. So this works as you would expect with SKIE. And again, the same way in Kotlin, there was no source incompatibility. The same works with SKIE. The source is the same for suspend functions. Looking at flows now. Ignore the errors or warnings here. These are not really important right now. But we had to implement the flow collector, as you've seen in Kotlin. And then we had to pass it in to get the light state. We have to first cast it to string, which is not safe. And then if we toggle the traffic light, well, actually I need to move back to Kotlin sample. When we toggle the traffic light, it goes red, green, yellow, and keeps ticking up on the update time. If we toggle it off, it keeps going. Again, let's toggle it a couple times. And now you can see it just keeps going and keeps going. Compare that to SKIE code. Not only is it vastly cleaner because we can use the for await directly, it also keeps the type here. So new light state is actually string that we would expect, and we can just directly save it. And going to our SKIE sample, if we toggle the traffic light, it goes, toggle it again, it stops. Both the traffic light and the update timer. Now default args are a little different. In here we see that you still need to pass them in the same way with the bad SDK. But with SKIE, by default, you would have to do that too. However, with SKIE, you can use annotations to configure these and say that you do want to enable default arguments. The reason why we have them disabled by default is that we're working on more performant implementation, and the current one is rather slow, especially for data classes. So it's off by default, but if you need it, you can enable it on case-by-case basis. Lastly, I'll touch on generics, but just a little bit because it's a little more complicated. So you can see how much code is needed to use the generics here, because we can't really use integer from Swift, because the Swift one is not a class, but all Objective-C classes, which Kotlin classes are visible as Objective-C classes, require class types for generic parameters. We need to use Kotlin int and then this int value property on it to get Swift integer. And we lose all of the information from this loses generics, and this map also loses generics. While SKIE doesn't really change generics or how they work, at least not now, it has one new feature that allows you to change and replace Kotlin code by yourself with Swift code and basically bridge however you want. Something I've done here is this generic showcase is actually a Swift class, not an Objective-C one or a Kotlin one. But I don't need to import anything, and this isn't living in this Xcode project. Instead, it lives right next to the Kotlin code, so we need to open it in IntelliJ. I'm not gonna go into all of this. This is more of a sample of what can be done, but this is essentially replacing the original Kotlin class and boxing it inside of it. So it is using that generic showcase, as you can see here, the __ generic showcase. But from Swift, we have the Swift class, which can work as improvement for API that would generally be bad. So with SKIE, you can write any Swift code and put it right next to your Kotlin code. And then that Swift code is bundled directly into the Kotlin Multiplatform package, the framework that you then import in iOS in Swift. That means that you can improve your iOS and Swift developer experience tremendously directly from your KMP project. And with that, I'm gonna give it back to Philip to close us off.
So, to summarize, the problem we have is that Kotlin to Swift Interop doesn't support many of the language features that we commonly use. And based on what you have seen, I probably don't have to tell you that this is not a problem that we can easily ignore. So we need some solution. And as with many other problems, the first step towards that solution is to understand the problem. Fortunately, we've already done that in the previous part. So now we can focus on finding the solution. And unfortunately, we will find out that on our own, we can't do much. The best we can do is to avoid or limit the usage of the problematic features to minimize the damage. That's not great, of course. So we need some help from the tools that we can get, and in our case, that's SKIE. As we have shown, SKIE adds a lot of the missing features back again automatically. But SKIE doesn't support everything, and for the remaining features, the solution is to write your custom wrappers. Of course, that comes at the cost of some manual work, but this investment might make sense in some cases because with a little bit of attention, you can get a near perfect Swift API for your Kotlin framework. At this point, you might have heard about the project called Swift Export from JetBrains, and you might have a question if the Swift export will solve this problem. And the question is a little bit more complicated. It's yes, but also no. And to unpack the reason why, we have to look back at the diagram of the three languages. This is the state that we have right now with the Objective-C export. Now, if we switch to the Swift export, we get this. There are two key things to notice here. The first one is that the arrow from Swift to Kotlin is now unidirectional. That's because Swift export deals only with this part of the Kotlin Swift interop. It will not add a better way of calling the Swift code from Kotlin. And the second thing is that, as you might have noticed, the two languages didn't get any closer to each other just because we removed Objective-C. And to be fair, that's not exactly what would happen. The languages would get a little bit closer, but not much. Certainly not as much as what we are used to from the combination of languages like Kotlin and Java or Swift and Objective-C. The reason why is because of something I like to call the semantics gap of the two languages. This is a concept that tells us that the Kotlin and Swift are syntactically very close and seem similar, but in fact they implement certain things with a very different philosophy, and therefore the things underneath in the language work very differently. To give you some examples, let's for example look at the generics. In Kotlin, generics are implemented using erasure at runtime, similarly to how Java JVM works. Whereas in Swift, it works more like in C++ because it's doing an instantiation. Plus, in Swift, custom types written by user cannot support covariance and contravariance, which are important features in Kotlin that we use every day. Another example are the default arguments, which are much more powerful in Kotlin than they are in Swift, because in Kotlin, the expression for the default argument can access additional scopes. It can access the values of previous parameters of the function, and it can access its dispatch receiver, meaning it can use the this keyword. Neither of these two things are available in Swift. And the last feature that I want to mention are sealed classes or interfaces. Swift has a similar feature called enums with associated values, but as the name suggests, those are basically enums, and in Kotlin we have classes, and those are different enough to not be basically compatible with each other, even though they solve a very similar use case. So, if we could magically use Swift export today and enable it in your project, you would see that the syntax of the Kotlin and Swift would get better, but you would run into a lot of semantic issues instead that were previously hidden from you by Objective-C or the syntactic issues. But there are also other problems with the Swift export, and one of them is that no, we don't have it right now, and it will be available soon, maybe. But we have to explain what soon means in this context, because we talk about compilers and languages, and in this realm, soon is very long time potentially, because compilers are extremely complex pieces of software. So if you remember quite recently with the K2, the refactoring of the front end, this also was taking quite a while to achieve. So I wouldn't expect the Swift export to get to the same level of stability that we have with Objective-C today for at least a couple of years. And the last issue I want to mention is that the Swift export will not be backwards compatible with the Objective-C one. And that's a big issue, but also understandable one, because if you want to improve the syntax, you have to change it, and if you change it, you will probably break a lot of existing code. Obvious question is if there is a migration path, or if there will be one, and the answer is not really, or at least not one that is obvious now. Certainly, it will be something that requires a lot of manual work. And associated problem with that is that once you have a lot of code written in some language, that code might take a very long time to be migrated to the new language or new version of the language. And we can look at the history and, for example, Python 2 and Python 3, look at how long it took to migrate from one language, one version to the other. And today, there already is a lot of existing code in KMP that uses the Objective-C export. But going back to SKIE, we knew all of these issues when we started development of SKIE, and therefore from day one, we've designed it to be incrementally adaptable because this is extremely important in practice. So, in contrary to Swift export, we want to support existing projects now, and therefore it's not all or nothing, and we've achieved that by providing a very flexible configuration for SKIE, which allows you to enable or disable certain features for certain declarations, classes, functions, or whole packages, or entire project. And therefore, you have full control over when you migrate and what parts of your code base you migrate. And we also, of course, we have a migration documentation that supports you during the migration. And for teams that do not have the time to perform the migration but still want to use SKIE to its full potential, we offer an optional professional support during which we can help you migrate the code. In conclusion, when you design an API for Swift developers, you need to keep in mind that there are certain limitations that in some cases are quite significant. You should use SKIE because it will definitely make your life much easier. And for cases where SKIE isn't enough, you can write Swift wrappers. And if at any point on your KMP journey you became uncertain about the direction it goes, don't be afraid to ask for professional guidance from Touchlab. The last thing that I wanted to mention is that if you already use SKIE, make sure to update to the newest version, because in 0.8 we've added support for K2, support for the custom Swift wrappers that we've mentioned today multiple times, but we also have a preview support for using flows with combine, and maybe more importantly, there is a support for collecting flows directly from Swift UI. That's all from me. Thank you for your attention.
And we're live, I think. So, thank you everybody for coming. We're now going to have a Q&A. I'm mostly going to not talk, especially because the one technical snafu is that I get an echo about 300 milliseconds after I talk. So, you're going to see earmuffs if I need to say anything. Anyway, here are our presenters. We got a bunch of questions, and let's see how it goes. The tip to the presenters, please read the question and then answer it if you're going to answer something. And if anybody else wants to do anything, just bear in mind there's like a minute delay between when we send and when you see it. So pop your question. It might be a little bit, and I'm going to stop talking.
The best
All right.
place to start is at the beginning.
Okay, let's start.
Why are you here?
Do we start from the bottom or do we go from the top?
Beatrice has
Okay.
Dealer's choice.
been showing signs of
Let's start with the latest
depression.
one. Although,
She's also
do
been very,
we
very angry
have
with
it
us.
working? I see black. I still see
She
black
saw us having
screen
sex.
Hold on.
on YouTube.
Apologies. Let me start that over. The second technical snafu. There's a lot of buttons here. We have a live switcher, semi-professional thing going on. Apologies again. Here's the folks. We're going to do question and answer to answer those questions you just had. Dealer's choice, and
I lit
my
some
headphones will be
candles
on and I'll be
and,
not talking,
played some
and
music
yada yada. Okay, go.
and got myself in a position.
All
that
right.
wasn't,
So
very
let's
easy
start
for me
from the
emotionally.
latest question, and then we'll
It's
roll
called the
back.
Congress of the Dead.
So what happens to SKIE
where-
when or if JetBrains will add direct Kotlin to Swift export support? So as far as we know, JetBrains is working on Swift export that Philip mentioned. The idea currently is we don't really know like how it will look exactly. So once it's closer to being done, being ready, we will probably want to add a migration support to SKIE. So imagine being able to toggle Swift export migration, right, in your Gradle. And then SKIE will generate that same Swift code. So you will be able to slowly migrate to it without having to without having to. Sorry, I read a comment and that threw me off. Basically, without having to switch directly to Swift export, because that will probably mean that you have to rewrite everything. But we'll see. The closer we get to it, we'll see what it means to use Swift export. Still really far away.
I think we also got one question that we failed to answer due to YouTube's great comment section that basically lost our response. And the question was about the way to profile the compilation time. And there the answer is that it depends on where you want to, which compilation time you want to profile, if it's in Swift on the Xcode side or if it's in Kotlin in Gradle. For Xcode, there I think is a built-in flag or something like that that you can use, and it will print out the times that each the compilation step takes, and it should be good enough for KMP purposes, because usually what will happen is that the task, like the build step where you call Gradle, will be the one that is a problem, and the rest will be fine. So in practice, we should look on the Gradle stuff, and there Gradle fortunately is a regular JVM program. So the same techniques that you can use for profiling JVM applications work there, with the only caveat being that you must make sure that you are profiling the right process, because sometimes the compiler spins up a separate daemon process that performs the compilation, and therefore it's oftentimes better to just force it to run in process with the Gradle daemon. And if that is like too advanced, then a simpler way is to just use the built-in profiling in Gradle, which will tell you at least the times each of the tasks takes, and this can be a good indicator of like the initial problems. But if you want to profile the compiler itself, then you have to use the classical JVM profiling.
There was a question about whether we communicate with Apple about Xcode and stuff. It's complicated. We did take part in WWDC code, not code labs, but labs, where you have basically you can ask for time with Apple developers. So we were able to talk to them, show them some things that we're dealing with, and hear their feedback on how some of those things can be figured out. But as of now, I'm not aware that we would be in like direct communications about like Touchlab and JetBrains. We have close relationships and direct communication line, and we talk a lot. But I don't think we have anything like that with Apple. Is that correct, Kevin?
No, I'm pretty much go to the Genius Bar. That's about as direct of a connection, and a handful of folks. But at JetBrains and Google, it's a whole different story.
Okay, do we have other questions? Seen that Philip's been responding to all the questions in the chat during the live stream. I can quickly talk about some of those things. So, for example, the being able to convert async sequences back to SKIE flows. It's not as simple as like just taking the same implementation we currently have, and we would love to hear more about use cases for that, and like based on that we can see if that would have higher priority. But so far, because usually it goes from like flows go from Kotlin to Swift and are consumed in Swift, we haven't seen much need to implement the other route. Always interfaces.
Yeah, here like the answer really is the usual. It depends.
Yeah, my usual joke is, everyone spends their first few months putting expect actual everywhere, and then the next few months ripping it out. I would say helper functions, like low to default implementation, especially in library work, is very useful. Everything else, not really.
Yeah, like especially like having something in expect might make sense, but writing your entire applications around that concept might be a problem in the later, because there are certain limitations that you might not run into immediately, and once you do, then the only way to around them is to refactor your code base.
To actually address that particular use case, like I would make it just logic in the interface and let the Kotlin side delegate the flow and everything else, rather than having the flow explicitly implemented. Do you know what I mean? Like the question that's in there. Anyway, that's my thought.
We just got word, I would say, from our team that we should answer all the questions, because it may like because of YouTube comments that those may get lost. So let's go from the top real quick and just go through them one by one. So we already answered the profiling. Let's see. Next one was, are there something that could be done in Xcode or in Swift, which would improve iOS developer experience when using KMP? But and this is something Apple would do. So from what we've seen, if they improved how Swift Package Manager worked and how it interops with other build systems, that would probably mean we could interact with Gradle more, like more directly, and improve maybe even debugging as well, and also being able to add plugins to Xcode that would contribute more than just what's currently available, which I think is like code formatting, but nothing really we can really add language support at this point. And that would be it, I think, for the stuff that Apple could do. That would be like low-hanging fruit, I would say. Everything else would require a lot more from them, and I don't think they would even do the low-hanging fruit. Philip, go ahead and take the next one.
Yeah, that's about the comments in Kotlin to Objective-C interop. So and the question is if it's possible, because the iOS developers would like to see the comments when they look at the framework from Xcode without having to dig into Kotlin code. And the answer is yes and no. There is a compile flag, experimental one, that you can enable during the Kotlin compilation, and that flag will cause the Kotlin compiler to include the comments in the klibs. And then the Kotlin linker will pick up those comments and put them in the Objective-C header. And as someone in the comments mentioned, this isn't always that great because the comments get messed up in the header occasionally. And also the issue is that SKIE currently doesn't generate the comments in the Swift generated code. And our answer there is that we are aware of this issue, and we have this as one of the high priority items on our to-do list to resolve, both by adding the comments into the Swift generated code, but also by improving the overall readability of the Objective-C header, which will also mean we will have the comments there in a better way than what is currently available.
Then we answered these. What's next? Code samples, how to do Swift bundling. Yeah, we plan to do something like that. As Philip mentioned, it's something that you just put Swift next to your code. But I agree that adding like examples of what could be solved by that. If you want to see it, you can go to the Bad Swift Simulator repo, and the generic showcase is implemented using Swift bundling. So this is something you can take a look at, how that works and how that's implemented. Then
but hopefully we will get to writing the article,
oh, yeah.
which explains how to actually use it, because it works, but also you still need to open IDE to write the code ideally and know how to debug issues that can happen with it. So
Then I think we have a question from Rich. Are you using klib under the hood for the Swift wrapper use case you demoed? I hope I'm understanding the question correctly. Basically, we're using SKIE's Swift bundling support, which allows you to write Swift code kind of next to your Kotlin code, and then SKIE takes that code and compiles it against your Kotlin framework. So under the hood, it still uses the original class, and it's basically wrapped in the Swift class. There are currently, it's recommended that you only use this with bundling inside the KMP project you're working on, but we do have support for libraries on our roadmap.
Yeah, and like in terms of like implementation, we are using klibs because we store the code that you write in Swift inside the klib, and only like at the end of the linking process, it's extracted from the klib and it's using SKIE to bundle it to the framework.
We have a question replacing CocoaPods KMP binding to SPM KMP binding. I'm not sure I understand that question.
Yeah, so I assume it's about how to integrate KMP into Xcode. I hope. In that case, I think our current recommendation is to not use CocoaPods and instead use like the direct integration that is using the embed Kotlin task or something like that, which basically means you need to like call Gradle from a run script inside Xcode, and it will like more or less set it up for you directly without having to introduce a package manager of some sorts.
Yeah, definitely. Unless you already have like this SDK that you built on CI and then deploy to your iOS, we generally don't recommend using SPM because as all of the limitations that SPM brings, you basically have to build a lot more code than you would with the direct embedding. Yeah. So the question, the continuation of the question, replacing the CocoaPods in the shared Kotlin lib. Yeah, basically the recommendation at this point is to get rid of CocoaPods entirely and instead use the embed and sign for framework for Xcode or something like that. It's a task in Kotlin that when you call it from a run script directly from Xcode, it will make sure that the framework is built only for the architecture that you're currently building for, and only the build configuration that you're building for. CocoaPods works similarly, but it was way more involved. And and we also have, I think, a blog post about that, how you can handle it. But moving from CocoaPods to Swift PM, unless you have like a proper use case for it, which might be the SDK approach, where something else builds the Kotlin and it's versioned separately as a library, we would not recommend doing that because of all the limitations.
Have we answered the question about what happens to SKIE when JetBrains releases the Swift export?
Yeah, I think that was our first.
Okay.
Yeah. Next time I can go from latest to all this. That was not a good idea. Do we have other questions? Or did we forget to answer some? So Alexander question, what are recommendations for the use case where common module is stored in different repository rather than iOS, Android apps? Some modules or something? This is a great question for Kevin, so I'll let him answer it.
Hold on one second. Okay, I've been told that I had an echo, so I'm doing some tap dancing here with the audio. Can you hear me? Yeah, you can. I can see the output. So I'm going to share a picture of Mission Control over here after the stream just to show you how ridiculous this whole setup is. Okay, the question is, what are your recommendations for use case for common modules stored in a different repository? Well, not only is one of my recommendations for that, or our recommendations, sorry, not to take ownership of everyone else's effort. We have multiple blog posts and things that went out this week, and it's been something I would say it's been my obsession for quite some time. That is what you should do, is have a separate repo in the usual case. And a blog post went out yesterday. One of our new updated recommendations in 2024 is don't share with binaries, because for an iOS developer, like Android developers already have a much bigger advantage with KMP, right? Like they understand Kotlin, they understand the Kotlin ecosystem, they've watched the blog posts, they've participated in view model, no view model, they understand coroutines, all that stuff, right? And a binary dependency in the JVM world usually includes a source jar. So if you give a binary dependency to an Android developer, they can browse the code, they can debug the code, they kind of get the code. The folks that need the most visibility and the most exposure to Kotlin, if your intention is for your team to adopt KMP more broadly, if that's the goal, then it's the iOS developer. And the iOS developer experience is, even if they were equivalent technically, it's going to be worse because they have to learn so much stuff, and it's just a new ecosystem. They're not even remotely equivalent technically. That's what this whole live stream is about. Like, we're trying to get the iOS developer experience maximized within the context of what's available now. All that's to say, share source, don't share binaries. Now, how do you share source? Get submodules. I'm sure somebody out there is like, I love submodules. Nobody else likes submodules, and you know that. So it's safe to say nobody likes submodules. And there are reasons for that. It adds the complexity right up front. You can get into trouble real quick. It sucks. We have a tool that was released recently called Git Portal, which essentially just uses a bunch of, a mix of, they call them porcelain and plumbing commands from Git to perform, I wouldn't call it magic, I would say just whatever. Look behind the curtain, it's not magic, but sharing source between repos in a way that is not like Git submodules and should be fairly straightforward. And a lot of the heavy lifting is handled by CI. So take a look at that post. There are two modes for Git Portal. Essentially the library publishing mode. So instead of just pulling in binaries, you pull in source based on a Git tag. And then if you want to really start to get into a groove for both teams to be developing, Git Portal has this bidirectional mode where if you're building an Android, you just worry about Android. You don't worry about breaking iOS or implementing iOS. You just change the code all in one repo. And if it works, and you commit in your normal process. And CI will handle the staging of that change in KMP, that such that the iOS side, when they're ready, explicitly can import those changes, test them, fix them, whatever you're going to do, push PR and do the testing, and that'll go through. It handles that automatically, magically-ish. I mean, there's some caveats, and there's current development going on. But our current recommendation is, number one, definitely have a separate repo. Number two, have eventual consistency with your KMP, because if you are able to get to the point where you can merge all of your repos into one place, a mono repo, although, again, never mind. Nobody likes me using that term because they're like, well, the server's not there. Okay, never mind. I said never mind. Anyway, all of your app code is in, if you put all your app code into one repo, any change you make to the KMP, if you're editing the Android app, explicitly, unavoidably will impact the iOS app and vice versa. And what that impact is, you're going to have to guess, unless you're going to make a change on this side and then open up the thing and try to implement it on both sides. And it couples your teams in a way that is not great when things are calm, and it can be a lot worse than not great when you're bumping up against a release schedule or a deadline. And even worse, like, there's a long post coming up about this, but merging teams is not as necessarily, it's certainly not easy, and it's not necessarily what you want to do for practical reasons. And even if you have people training and getting up to speed and everything's going great, and and everyone knows how to do both platforms equally well, which is kind of a pipe dream. Anytime you have a new person join a team, they're starting at zero. So it's like, anyway, do we have recommendations? We definitely do. They're on the they're on the website. I got a lot of thoughts about that, and I'll stop talking. I have a tendency to go on. All right, I'm going to mute, and then hold on, guys. I got to turn on the other things where my echo was happening. Give me like 5 seconds.
All right. Do we have other questions?
Yeah, I mentioned maybe before that I would add to the previous topic that this is just a general recommendation, right? Like, if you are doing something and it works for you, like, don't change it just because we've told you that there is some other way. Like, in general, existing teams that don't have everything working right, this might be a good option for them to try. Don't break your working setup because of it or something else. Yeah.
And I also add that we always appreciate when we get feedback on this, or feedback of what works, what doesn't work for your teams. So reach out and let's chat about that.
Hold on. Where should they reach out? Hold on. Now I got to do the other thing.
We need to fix our setup for next time. Yeah, so we are on Kotlin Lang at Touchlab Tools. So that's one way to reach us. Other way to reach us, on our website, we have contact forms, if I remember correctly. And then, of course, on all of our repositories through discussions and or issues.
And if you happen to be coming to JoyCon New York, we're going to be all over it. So catch us there or whatever. And back to you too.
All right, so since we have no other questions, I think we can call this for today. Unless I'm forgetting something, but hopefully I'm not. So thank you everyone for your attention. Thank you all for coming, and everyone who's watching this as a recording. Everyone have a good one.